So you already know about the three great vessels on the base. You have the superior vena cava, the aorta, and you have the pulmonary trunk. What I want you to remember is this is a pumping mechanism. So the atriums contract at the same time. When they pump through, the blood comes from the atriums into the ventricles. When these valves shut after that pumping is done, that's your first heart sound. If you listen to your heart, it goes lub dub. It goes bum, 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 bum. That first heart sound is when the atrioventricular valves shut. Once they're in here, then the ventricles will contract together. One pushing it into the lungs, the other one pushing it into the rest of the system. Going through what they call semilunar valves. Once the blood goes through those and those semilunar valves close, that's your second heart sound. So the lub, or your first heart sound, is the closing of the AV valves. Your second heart sound, or the dub, is the closing of the semilunar valves. All right, so now that we have that understood. And remember that you have the right side of the heart is pumping blood to the pulmonary structure. The left side of the heart is pumping blood to the systemic and coronary structures. So let's start at the beginning. Arteries take blood away from the heart. Veins bring blood back to the heart. Well, they have to leave a chamber and they have to return to a chamber. And there's only 4 chambers to do that. So, observation number 1. All blood that returns to the heart, all blood from your entire system, always comes back to the right atrium. So through the inferior vena cava, this is draining all the blood from your lower extremities and your abdominal pelvic area. From the superior vena cava, it's draining everything from the thoracic, head, and upper extremity and neck, all going to the right atrium. And then way over here is what they call an opening to the coronary sinus, which is blood being drained from the myocardium or the coronary circuit. So all the blood that goes back to the heart, all of it arrives at the right atrium. So everything happens from the right atrium forward. Okay? Now once you get into the right atrium, you have an opening here for the inferior vena cava, you have an opening there with the superior vena cava, and you have an opening here for the coronary sinus. Now you notice that there's no valves on any of those. Because the way that the mechanism of the heart pumping is that when this is pumping through here, it causes increased pressure that actually causes a bit of resistance here, so the blood doesn't pump back up into the vena cava. So now we have the blood in the right atrium. Once the right atrium contracts along with the left, but we'll get to the left later, it's going to push blood through here, not because it has such a strong contraction, but because of the pressure that's building up in the atrium and the lack of pressure that's in the ventricle. Pressure builds up here. What's going to happen is it's going to overstimulate the AV valves, and the blood's going to come through here as it compresses. Now these AV valves are there to protect not the blood going in, but blood coming back out. So the blood is pumped from the right atrium into the right ventricle. As soon as the amount of blood that is necessary to be in here is full, these shut. And you have something called the chordae tendini, which are literally tendons attaching to the AV valve. Why do they call it AV valve? Because it's between the atrium and the ventricle. So it's the right atrioventricular valve. It has another name. It has 3 cusps, so they call it the tricuspid. You have to know all those names too. So as the blood is being pumped from right atrium to right ventricle, once this is full, these valves shut because of pressure again. Pressure now drops in here, increases in here, the valves shut. These cords stop the valves from going back, we'll call it inversion. Stop them from going back up into the atrium, so you have regurgitation. So the cords are not there to pull the valves, they're to stop the valves from going back up in the atrium. All right? So now we're in the right ventricle. Before this blood can be pumped out into the rest of the system, we have to pick up oxygen and drop off CO2. So what we end up doing is, when this contracts, it pushes the blood up through the semilunar valve, which is called the pulmonary semilunar valve, into the pulmonary trunk, into the pulmonary arteries, going to the lungs. Any vessel that goes away from the heart is an artery. Even though in this particular case, this is the only place in the body that has an artery that does not have high concentrations of oxygen. Hasn't been to the lungs yet. So as the right ventricle contracts, the valve's shut, the pressure builds, and they go through the semilunar valve, what's called the pulmonary valve, to the pulmonary trunk, and to right and left pulmonary arteries, taking the blood, low oxygenated blood, to the lungs. Gas exchange takes place, they pick up O2, and then they come back. So they come back to the left ventricle from the lungs as left pulmonary veins. But again, they've already been to the lungs now, and so the pulmonary veins are oxygenated. The only place in the entire systemic system of 65,000 miles of blood vessels that you have an artery with low and a vein with high oxygen content. Everywhere else, it's just the opposite. So it's an exception to the rule. So the blood comes back from the lungs, goes into the left atrium. Pressure builds, you get a contraction again that pushes it from the left atrium to the left ventricle. The valve's therefore shut, the chordae stop it from going too far into it, and now this fills. As this fills, it builds pressure. I want you to notice the thickness of the wall of the left ventricle compared to the right ventricle. Why is the left ventricle so much thicker than it is on the right?
Pushes the rest of the body.
Because it has more resistance. You have to push the blood from the left ventricle out to the entire systemic system. On the right ventricle, you just have to push it to the lungs. So you'll always find, when we dissect sheep parts, you're going to find that the left ventricle is going to be quite thick. And this is the muscle here that when you exercise, that's the muscle that you actually are exercising to make sure that it's strong, thick enough, and has enough contraction to force the amount of blood out. All right. So this begins to fill. Then the blood, once this contracts, is pushed out through here, and up inside there is another one of these valves, but it's part of the aorta, so we call it the aortic valve. It's still a semilunar valve. So once it goes up to the semilunar valve, goes through the aortic valve, goes to the ascending aorta, the arch of the aorta, and down through the descending aorta, and takes it all the way systemically to everything below the heart. And you'll see there's three arteries coming off the arch. There's the right brachiocephalic, there's the left common carotid, and the left subclavian. These are arteries, three of them, that feed the upper extremity, the neck, and the head. Why do they put it right at the apex of the heart, or apex of the aortic arch? I mean, is that designed that way for a purpose, or is it just happenstance? How many here have ever roller skated or ice skated? You ever got one person standing right here and got like 5 people on the end and done a whip where you get everybody out there? The person on the very end sometimes can't hold on because they're going so fast. It's called centrifugal force. So as the heart is pumping, this blood comes up here and then makes a quick turn. And as it makes that turn, it forces all the blood, not all of it, it forces a large percentage of the blood up through those 3 arteries to feed the neck, arms, and head. The rest of it goes down to the rest of the body. And that's really the circulation. Now, there's a couple things we have to talk about. Inside the heart, in between these chambers, you have what they refer to as septums. Okay? Literally, inside your heart, you have a cross of a septum. So you have the interventricular septum, which is between the two ventricular structures. You have the interatrial septum, which is between the 2 atriums. And then you have Then you have the interatrial ventricular septum, which goes between the atriums and the ventricles. So you literally have a cross inside your heart that forms this and this. And those are the septums that separate all these. So let's just do a quick review. You have 4 valves in the heart. 2 AVs, 2 semilunar. The AVs are the large ones that separate the atriums from the ventricles. The semilunars are separating the ventricles from either the pulmonary trunk or the aorta. Only 4 valves. You have chordae tendineae that stop the valves from going back up in the atrium for regurgitation. You also have these chordae tendineae are attached to muscles inside the actual ventricular structure. They're called papillary muscles. Up inside the atrium, you have pectinate muscles. And then, of course, you have the myocardium. One last thing. You have something referred to as trabecular carnac. Inside each of the ventricles, you have this trabecular pad. Remember what the trabecular pad looked like in bone? All right? Remember you had compact bone, and then you had spongy bone. Spongy bone was trabecular in pattern, which means it has all these different structures that make up kind of a scaffolding effect. Well, inside the ventricles, you have trabecular carnac. It isn't smooth. Because what happens if you put blood inside of a smooth container and try squeezing it out? you lose the ability to direct it appropriately. But if you can, on the inside wall, you have a trabecular pattern which makes it very irregular in shape. When the heart contracts, it controls the ejection of the blood much better. And interestingly enough, the heart doesn't contract like this. The heart contracts here and goes like this. So it starts here and it contracts this method here. So it actually contracts from inferior to superior, forcing the blood out. So let's go through real quick. We'll trace a drop of blood. I'm going to tell you this slowly to begin. Okay? So I say, because I forgot to tell you this, on your final, in addition to your quote, you're also going to have to trace a drop of blood throughout the entire body. And it's actually very easy to do.
Is that actually credited?
Yes. So, what we have is, we're just going to go through the heart. It's like 14 or 15 different things you have to know for this. It's very easy. So let's say you're tracing a drop of blood from the inferior vena cava. So let's walk through it. Just follow the arrow. So this is how you want to do it. So you go from inferior vena cava to the right atrium into the right ventricle, through the tricuspid valve or the right atrioventricular valve. Into the right ventricle, it pumps out through the pulmonary semilunar valve to the pulmonary trunk. Goes from the pulmonary trunk to the pulmonary arteries, because these are vessels going away from the heart. Goes to the lung, has gas exchange, picks up O2, and it comes back to the heart through the pulmonary veins. Goes into the left atrium, through the left AV valve, which has two other names. It's called the bicuspid, and it's also called the mitral valve. Once it gets into the left ventricle, then it pumps out through the aorta valve into the ascending aorta, the aortic arch, and descending aorta, or any one of those. That's it. That's all you have to name. Okay? So it's not too difficult. Let's do it again. Wow. This is how we'll take it from the superior vena cava. Where does all the blood return to in the heart? The right atrium. So you have the superior vena cava coming to the right atrium. Through the right atrium, it pumps through the right AV valve or the tricuspid valve into the right ventricle. From the right ventricle up through the pulmonary semilunar valve to the pulmonary trunk, to the pulmonary arteries, to the lung, exchange, comes back through the pulmonary veins into the left atrium. From there it goes from left atrium through the bicuspid valve or the left AV valve or the mitral valve into the left ventricle. From the left ventricle then it pumps up through the aortic semilunar valve into the ascending aorta, the aortic arch, and descending aorta, or those three arteries as well. That's all you have to know. We'll have a quiz next week about tracing and dropping blood in the heart.
Really next week? This week right after the test?
So, we have to make up some quizzes. All right, so that's the anatomy inside of the heart and how to trace and drop the blood. Now,